We're moving on to 7.3. This is actually the last section in this chapter, and it deals with geometric sequences. What sort of pattern do geometric sequences have? Multiplication. Okay, if you're going up, you're multiplying by a number bigger than 1. If you're going down, you're multiplying by a number smaller than 1. So what would the pattern in this case be? Multiply by 2, so the next two terms would be 24 and 48. Okay, this one, the pattern is divide by 3, but we never divide. Instead, we times by a third. So 27 times 1/3 is 9. 9 times a third would be 3. Okay. Is this geometric? Well, it's alternating between positive and negative, which means I have to multiply by negative. And 250 times negative 1/5 is negative 50, times negative 1/5 is 10, times negative 1/5 is 2, negative 2. So yes, this one's geometric. What about B? 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108, so yes. What about 15, 20, 25, 30? That is add 5. That one is arithmetic, so we click the not geometric button. All right. So here, this is a sub 1, and I want to know what is a sub 14. What's the pattern? Timesing by 2. How many 2 multiplies by 2 do I need to go from a sub 1 to a sub 14? No, it won't work. So I need to get from here to here, I need 13 multiplies by 2. So that is 2 to the 13th. Right? Because it's 2 times 2 times 2 times 2 times 2, 13 times. So I need to take 3 and times it by 2 to the 13th. So 3 times 2 raised to the 13th. Does that make sense? Okay. What's the pattern here? Timesing by 5. So how many multiplies by 5 do I need? I need 10 after this. So 1 times 5 to the 10th. So 5 to the 10th is that number. Okay. Yeah, that's the answer. Geometric sequences can get very large very quickly. All right, what if I had 1028, 5, 14. Hang on. I'll mess this up if I do it in my head. Okay, let's do this. 8,902, and then 4096, and then 2048. Okay, and I want a sub let's say 9. What's the pattern? multiply by a half. How many 1/2s do I need to get from here to here? 8. Now, when you do fractions, you have to be careful. So I need to do 8192 times 1/2 to the 8. But whenever you're putting an exponent on a negative number or on a fraction, make sure you put that in parentheses. Anytime you're putting an exponent on a negative number or a fraction, then make sure that you have parentheses around it. So 8192 times 1/2 raised to the 8th is 32. We get that? So here you just have to decide arithmetic, geometric, or neither. So the first one, what pattern do you notice? Multiply by 3, so it's geometric. The next one, subtract 5, so it's arithmetic. And the next one, so it's plus 5 plus 3 plus 5 plus 7. That one is neither. Okay. That is not what I meant to do. I don't know how I did that, but... Okay. So the first term is 8. The common ratio is 1/2, and we want term 6. Yes, so we start with 8. How many 1/2s do we need to go from term 1 to term 6? 5. Okay. All right. So we want the explicit formula for arithmetic and geometric. Now remember, an arithmetic formula is so the arithmetic formula is a sub n equals d times n plus a sub 0. Okay, which is a little weird because a sub 0 is not part of the sequence. Okay, for the geometric formulas, we're going to make it a little bit different. We're going to say a sub n equals a sub 1 times r raised to the n minus 1. I think that's the way they should do it. Let's see if they change their format. Okay, good. So those formulas are up on the posters above my desk. So neither of the the first one of those is arithmetic. What's the pattern? Minus 5. So over here, this is a sub 1, and the pattern, the common difference, is subtract 5. So we say it's arithmetic, and what will the formula be? A sub n is the common difference, negative 5, times n plus what? plus whatever would be right here, 7. So we stick in whatever would happen before a sub 1, even though it doesn't exist. It's not part of the sequence. That's the number that goes in the formula. Do you guys need to see another one of those? Okay, let's say my sequence was 5, 12, 19. What would the formula be? We're adding 7. So a sub n is 7n plus, in this case, it's minus 2. So if we take this number and we backtrack one day, so we subtract 7, we get negative 2. And that's what goes in the formula. Okay? Now, with geometric sequences, we don't need to do that. Geometric sequences say, take the first term, so in this case, 24. So 24 times the common ratio. What are we multiplying by in this case? Close. Negative 1/2. So negative 1/2, and then we raise it to the n minus 1. Which is a little strange, but that actually makes one of our other formulas a little bit nicer. Okay, let's do another one of these. Okay, so this one, the pattern is plus 3. So my formula, a sub n, is 3 times n plus 1. 1 is the number that would happen right there. Okay. For geometric, here r is multiplied by 5. So it's 2 times 5 to the n minus 1. You guys understand that? Okay, we're not going to do this one. All right, that is it. Get to work.